Okay, well, welcome back everyone. So today we're going to be finishing up function transformations. We're going to start off with knocking out the homework from the last video. So we're going to start with, for number one, we have the base function is going to be x squared, and then for part A, we would like to shift it to the right by 3. So since it is a horizontal transformation, we're going to wind up replacing every x with what? So this is a horizontal transformation, which means we're going to replace x with, is it x plus 3 or x minus 3? Well, since it's a horizontal transformation, it's the opposite of what we would think. So if we move it to the right, we need to subtract 3. So every x needs to be replaced by x minus 3. So x squared becomes x minus 3 squared. And that right there will shift the function x squared to the right by 3. Okay? For part B, let's say we want to shift it down by 7. So since this is a vertical transformation, all we do is we apply the transformation to the entire function. So this is going to be the entire function, and then just do the transformation. So the entire function, I like to put the entire function in parentheses, and then the transformation, whatever it is. So with that in mind, I'm going to put the entire function, x squared, in parentheses, and then perform the transformation. I want to shift it down by 7, which means I'm going to subtract 7. And that's it. That will shift x squared down by 7. Alrighty? So let me clear this, and let's go to the next problem. Clear that. Yeah, there we go. So number 2, we had the base function, and it was x cubed plus 2x. And for part A, we were going to shift it to the left by 5. So left by 5. Okay? So this is a horizontal transformation since it's moving to the left. So horizontal transformation. And so we're going to replace every x with, well, it's going to the left, but it's a horizontal transformation, so it's the opposite of what we think. So we're going to add 5 to every x. So x plus 5. So every x is going to get replaced by x plus 5. So instead of x cubed, I'm going to get x plus 5 cubed, and then plus 2 times, instead of x plus 5. And that will shift the function x cubed plus 2x by 5 to the left. And you can actually run this in Desmos really easily. Just if you really want to make sure that it does correctly in Desmos, you can put a y equals in front of all this. You don't have to in most cases, but sometimes Desmos prefers that. So the next one for part B, we'll want to shift it up by 13. So this is a vertical transformation, and for that one, we just put the entire function in parentheses and do the transformation. So I'm just going to put the entire function in parentheses, so x cubed plus 2x, and then since I want to shift it up by 13, I'm just going to add 13. That's it. Vertical transformations are easy. It's the horizontal ones that are a little bit tricky. Okay? So that was number 2. Now let's tackle number 3, which is a little bit more challenging. So for 3, we have the base function is 7x to the 4th plus 3x plus 5. Okay. And first transformation we want to do is shift it right by 10. So right by 10. All right, so this, again, it's a horizontal transformation since it's moving, it's doing the transformation horizontally, in this case to the right, which means we're going to replace every x with what? Well, it's going to the right, but it's horizontal, so it's the opposite. So this is going to be x minus 10. Okay? So everywhere there's an x up here, I'm going to replace that with x minus 10. So I'm going to get 7 times x minus 10 quantity to the fourth plus 3 times x minus 10 plus 5. And that's it. That's exactly how you shift this whole thing up here 10 to the right. Alrighty, and last but not least, we want to go down by 10. So if I go down by 10, that is a vertical transformation. And so that's just going to be the entire function inside parentheses. And then I just perform the transformation. So first thing I'm going to do is put the whole function in parentheses, 7x to the 4th plus 3x plus 5. And then I'm going to want to go down by 10, which just means I subtract 10. And that's it. That's how you do that vertical transformation. Alrighty, so hopefully the homework went well. We are now going to, if this makes sense where you can do the horizontal transformations, you wind up replacing every x with whatever that transformation is. Vertical transformations, you just take the whole function, put it inside parentheses, and then do the transformation. If you've got that, the rest is not going to be that bad. Alrighty, so let me clear this and let's get started. Okay, so the first of the two sets of transformations that we're going to be covering in the remaining lecture are going to be flips or mirrors, so mirror transformations. And most people really like these, transformations. Okay, what am I talking about when I say mirror transformations? Well, if I have a function, maybe it looks like this, and I want to flip it, mirror it across the y-axis, now it would look like this instead, where this one would no longer be with us. So I just okay, so I want to take the original function, and let me draw that one back in, or attempt to, and then the new function, I'll do a dash like that. Okay, so this is one of the types of transformation. The other one, as you can imagine, instead of flipping across the y-axis, I'm going to flip across the x-axis. So this one is one of the types of transformations, and this one is going to be a different one. So let me put it like this. And then let's say I had a function that was, I don't know, maybe that. What I want to do is flip it across the x-axis so that instead of it looking here, it would be, oops, well, this is hard to do. I shouldn't have made it quite as complicated. Something like that. It would flip across, and now it would be on the bottom instead of on the top. So the thing about this is, which direction is the transformation taking place? So here it is flipping from the right side to the left side. It could be vice versa, but it's basically what I would get if I put a mirror up and then flipped it across from left to right or right to left. This is a horizontal transformation. This is a horizontal flip or mirror, either one. I'll use both of them as we go, more than likely. So if I want to flip a function across the y-axis, that is a horizontal flip because the function itself is flipping from the right to the left or vice versa. Now down here, I am flipping from the top to the bottom. So this one is a vertical transformation. So a vertical flip or a vertical mirror. Okay? So, like we had before, the vertical flip is going to be the entire function in parentheses, and then you apply the transformation. But the horizontal one is going to be replace every x with the transformation, whatever it is, okay? With the transformation. Okay? Now, luckily, the transformation needed to mirror something is extremely easy. It is not bad at all. Just remember, if I am flipping from top to bottom across the x-axis, it is a vertical transformation because it is going from top to bottom or bottom to top. If I am flipping left to right, right to left across the y-axis, that is a horizontal transformation. Okay? So with that in mind, here's what you do. For the vertical flip the mirror, if I want to go from flip something from top to bottom or bottom to top, I put a negative sign in front of the entire function in parentheses. That's it. A single negative sign. I've already got my function in parentheses since I knew it was a vertical transformation. I put a negative sign in front and it automatically flips it from top to bottom. Okay, now if I want to do a horizontal flip where I'm going from left to right or right to left, all it is replace every x with the transformation negative x. So all x's become negative x, and it's best to keep them in terms of the parentheses negative x because that negative needs to stay with the x. It's important. So that's it. That's how you do mirror transformations. If I want to go from left to right, I replace every x with negative x. If I want to flip top to bottom, I put a negative sign in front of the entire function in parentheses. That's it. So let's do some examples. Let me clear this. Let's say that I have for my base function, maybe x cubed plus 5x squared minus 10. Okay? If I want to do a vertical flip like so, I like this because it shows instantly I'm going from top to bottom or bottom to top. I am flipping vertically in space. So all I have to do for that kind of transformation is put the whole thing in parentheses, as always, since it's a vertical transformation. So x cubed plus 5x squared minus 10, and then put a negative sign in front of it. And that flips it top to bottom. Okay? If I want to take that instead and flip it left to right, all I have to do is replace every x. I'll even write this one out because this one is not quite as easy. Replace every x with negative x in parentheses. Okay? So instead of x cubed, I'm going to have negative x cubed. Note that it's parentheses in here. Plus 5 times negative x squared minus 10. And that's it. That will take this function and flip it across the y-axis. It will flip it horizontally because it's going from left to right. So far so good? Alrighty. Now that we've worked this, let's actually go to Desmos and verify that this still works. So, alright, let's go to Desmos. Okay, so here we are in Desmos. And let's see, what was that function? I forget what the function was already. Hold on, let me peek back at it. Okay, I just peeked. So now I can do this. So we have x cubed, and then plus 5x squared, and then minus 10. Okay, so we get this thing right here. I'm going to zoom out just a little bit so you can see the whole thing. So here we have the original function, and it's pretty distinctive what it looks like. So I just picked one at random that actually looks pretty cool. I'll zoom out a little bit more so we can really see it. Now, if I want to flip that top to bottom, where I want to, looks like I'm holding a mirror across the x-axis, all I have to do is take the function. I'm just going to copy paste. So there's the copy, and here's going to be the paste. Okay, the original function, and then all I have to do in order to flip it across is put a negative sign in front of it. And you can see what once was down is now up, and what once was up is now down. So it flipped it vertically. Okay, vertical transformation, you take the entire thing, the entire function in parentheses, put a negative sign in front, and you're good to go. Alrighty, now let's flip it horizontally, left to right, right to left. So for that one, I have to replace every x with negative x. This is going to be negative x cubed plus 5 times negative x squared minus 10. What do you know? There it is. It has now flipped left to right. What was left is now right, and what was right is now left. So there you go. That's how you do your mirror images, your flips, using function transformations, which is pretty cool. All right, so now that we've done that, let's go back and start in on the very last transformation. Okay, so the last type of transformation is going to be stretching and shrinking. And this is a little bit complicated, but it's not too terribly bad. So we're going to start with vertical transformations because they are by far the easiest. Okay. Transformation. I need a shortcut for that. That's too much. So vertical transformations. Okay. So if you want to stretch, if I want to stretch a function vertically, by some factor, all I have to do is put the entire function in parentheses, the entire function, because it's a vertical transformation, and then just put the factor as a multiplier. Okay, so I want to stretch a function by a factor, I multiply the entire function by the factor. So you can either put it at the front or at the end. Most people like to put it at the front. So factor times that entire function. Now I'm going to use an actual number. So for example, what if I want to stretch a function vertically? So here's what I'm going to use to denote stretching. Stretching a function vertically by a factor of 5. So I want it to be 5 times taller than it was. Well, all I have to do is take the entire function in parentheses and put a 5 out front. And that will stretch it vertically by a factor of 5. Okay, not too bad. Now, guess what I have to do if I want to shrink it by a factor? So if I want to shrink it or compress it, however you want to call it, stretch and shrink is what a lot of books say, but I don't remember what yours says, but that's in essence what's going on. If I want to shrink it, compress it, shrink a function vertically by a factor, or I take the entire function, put it in parentheses, and then multiply it by 1 over the factor. Okay? Or you could say you divide by the factor. In other words, you put the entire function in parentheses and then just divide by the factor. It's the exact same thing. Whether you multiply by 1 over or divide, it's the exact same thing. So as an example, if I wanted to, I usually indicate that I am shrinking it with the 2 little arrows facing like that vertically by a factor of, let's say, 7. All I would do is take the function, which I'm going to call EF, because I don't want to write that again, and divide it by 7, or 1/7 times the entire function. That's it. That's all you have to do to stretch or shrink a function vertically. Alrighty, so let's actually see what that looks like with Desmos, and then we'll worry about horizontal. So let's go to Desmos. Okay, so here we are at Desmos with that function we were using just a second ago. So let's say that we want to stretch it by a factor of 2. I want the peaks to be twice as big as they are right now vertically. So I put the entire function. I bet I've still got that copy and paste. Let's see. Boom, sure do. Okay, take the entire function and I multiply it. So I want to stretch it by a factor of 2. I multiply it by 2. And now it has been stretched vertically by a factor of 2. Pretty cool. Now if I want to shrink it by a factor of 2, all I have to do is take the original function and then multiply it by 1 over 2. Or take the entire function and then just divide by 2. It's exactly the same. Both of them give exactly the same function. Whichever one you like. Some people like to think about it as dividing. Some people like to think of it as multiplying by 1 over. I personally think it's more intuitive to think about your dividing, because if I'm trying to make something squishier vertically, I'm just going to divide it by the amount I want to squish by. So if I want to make it have half the squishiness, I divide by 2. Half the squishiness, half the vertical peak height, I am going to divide by 2 or multiply by half. Either one's fine. Whatever you prefer, totally cool. Alrighty, so that is how vertical stretches and stretches and shrinks happen. Boy, that's hard to say 3 times fast. So now that that's out of the way, let's tackle horizontal ones. Let's say I want to instead stretch or shrink it horizontally. That's way more complicated. It's not that it's more complicated, it's just not intuitive. So here we go. I want to stop, get out of here and go back to the blackboard. So let's do that. Okay, so let me clear this. All right, so here we go. If I want to do horizontal stretches and shrinks, here's what has to happen. Okay, let's start with stretches. So a horizontal stretch, okay, I know it's a horizontal transformation, so I'm going to replace every x by something. So let's say I want to do a horizontal stretch by a factor, whatever that is, by a factor. Oops, let's see, let me erase these two little dots, they don't belong. By a factor, some factor, could be 3, 5, 7, who knows. What I'm going to do is replace every x, and I knew I was going to have to do that since it's horizontal, with 1 over, my gosh, the factor, I'm getting right factor. Factor is that, there we go, factor, 1 over the factor, x, or x over the factor, whichever you prefer. Okay, so remember me saying that everything in horizontal transformation is the exact opposite of what logically it should happen? Same here. If I want to stretch it, I wind up dividing every x by the factor in order to stretch it by that factor. So for example, if I wanted to stretch it horizontally by a factor of 7, I'm going to replace every x with x over 7. So if I want to stretch it, I divide by the factor. I know, it doesn't make sense. All right, so now a horizontal shrink, and you can probably guess what's going to happen here. So for a horizontal shrink, or compression, or whatever you want to call it, I want to shrink it horizontally by a factor. I replace every x with, yep, you guessed it, x times the factor, or the factor times x. A little dot there. So for example, if I wanted to bring it in, shrink it horizontally by a factor of maybe 13, I'm going to replace every x with, drum roll, yep, 13 times x. Again, I get it. This is weird. So let's actually do a couple of examples with this and then go to the graph and see how it works. Alrighty. So let me clear this. Okay, so let's make the function maybe negative 3x to the fifth plus 7x squared minus x plus 1. We'll make something pretty complicated. Alrighty, so if I want to stretch it horizontally by a factor of 2, I'm going to replace every x in the original expression with what? Right, since I want to stretch it and it's a horizontal, it's the opposite of what I would think, so I'm going to divide by that factor. So x divided by 2. Or if you want, you can still use 1/2 x. It's completely up to you, doesn't matter which one you use. Alrighty, so in this case it would be negative 3 times x over 2 to the fifth plus 7 times x over 2 squared minus x over 2 plus 1. This is going to stretch it horizontally by a factor of 2. Okay? If I want to shrink it by a factor of 2 horizontally, if I want to compress it by a factor of 2, I'm going to replace every x with what? Well, since I'm trying to compress it, shrink it, I'm going to replace it with 2x, which is all there. There's no or for that one. So what does that look like? Well, it looks like negative 3 times 2x to the fifth plus 7 times 2x squared minus 2x plus 1. And that's it. So stretches by a factor, you divide by that factor if it's horizontal. Shrinks, you multiply by the factor. That's what you replace every x with. Alrighty, so now let's go over to Desmos and see what this looks like. So here we go. Okay, so here we have our friendly function. Now let's do some stretching and shrinking horizontally. So if I want to stretch it by a factor of 2 horizontally, I replace every x with x divided by 2. Oops. I have to make sure that I don't get my parens in the wrong spot. At 3 plus 5 times x divided by 2 squared minus 10. And as you can see, it has literally stretched it horizontally. So what used to be a peak here is now a peak over here, twice as far away. What used to have a line hitting the x-axis here is now hitting the x-axis here. So it is exactly twice as far. So that's how the stretches work. You divide by the factor you want to stretch it by. What about if I want to do a shrink, if I want to compress it? So if I want to compress it by a factor of 2, I change that into each x into 2x cubed plus 5 times 2x squared minus 10. And now you can see what happened. The red one is the original function. The green function is the shrunk version, the compressed version, and it's actually shrunk. It's been squished horizontally. It's now, instead of going from here to here, it's going from here to here, which is exactly half the distance that it was before. Notice it doesn't change anything about where the peak hits vertically. It's the same vertical distance. It just compresses it horizontally. Okay? So that is it. That is function transformations. I'm going to devote the remainder of the lecture just doing tons of examples. Might do more Desmos just to verify, might not, but let's tackle this, some nice examples. So let me kill this and get back to my blackboard. Okay, I'm going to clear this. Here we go. So let's say that I have a base function and I want to, let's say, base function x, first of all, let me write the base function, 3x to the fourth plus 5x minus 1. Okay? So, that 4 is bugging me. Let me try that again. To the 4. There we go. Now, let's say I want to stretch it vertically by a factor of 7. Well, in order to do that, all I have to do is a vertical transformation. So first thing I do is I put the whole thing in parentheses because it's going to affect the entire function. Alrighty? So how do I stretch it by 7? I multiply it by 7. That's it. That's how you stretch it vertically. Now if I wanted to stretch it horizontally by maybe a factor of 3, now I have to replace every x in the original function with what? Well, if I want to stretch it by 3, I replace it with x divided by 3, because this is a horizontal. It's exactly opposite what you would think. So I wind up with 3 times x over 3 to the fourth plus 5 times x over 3 minus 1. That's how you stretch it horizontally. Okay? Now, let's say that I want to shrink it vertically. Shrink it vertically by a factor of, I don't know, 11. How do I do that? Well, it's a vertical transformation, so first things I'm going to do is put the whole function in parentheses. And then what do I do to get it to shrink vertically by 11? Well, I just divide by 11, and it shrinks it vertically by a factor of 11. Or I multiply by 1 over 11, whichever one you prefer. Some people like one way, some people like the other. Just like that. But now let's say I want to shrink it horizontally by, I don't know, 5. Okay? So it is a horizontal transformation, so I'm going to replace every x with what? Exactly. Since it's a horizontal, it's the opposite of what I would think. So if I want to shrink it, I multiply by that factor. So I replace every x with 5x. So this becomes 3 times 5x to the fourth plus 5 times 5x minus 1. There you have it. Okay, and now a little aside up top. Let's say I wanted to flip it across the y-axis. Is that a horizontal transformation or a vertical transformation? Well, which way is the function moving? It's moving left to right. So that is a horizontal transformation. So what do I replace every x with? I replace every x with what? Exactly, negative x. That's how you flip it. So I'm going to get 3 times negative x to the fourth plus 5 times negative x minus 1. Okay? And down here, so we don't forget it, I want to flip this function across the x-axis, which way is the motion happening? It's flipping vertically. So this is a vertical transformation. So all I do is I take the original function, the entire function, put it in parentheses, 3x to the fourth plus 5x minus 1, and put a negative sign in front of it. And that flips it vertically. Alrighty, what do you think? Not too bad? Hope so. Alright, so let's work some more comprehensive examples. I'm going to put the full set of rules down, and then we'll do some examples. So here we go. Okay, so here we go. This is going to be the full list of transformations that you'll see. So let's start off with, let's do all the vertical transformations all at once. So we're going to do the vertical transformations. Actually, you know what? Before I do that, let me make a base function. So we're going to call our base function. Let's call it, won't have to be anything crazy, x cubed plus 5x squared minus 4. Okay? That's going to be our base function. We're going to do all the transformations on. So let's start off with vertical transformations. Okay? So first one is we want to go, and we're going to do all of our factors are going to be, let's say the factor is always going to be 3. Okay, that's a nice factor. All right, so if I want to go up by 3, what do? Take the entire function, put it in parentheses, x cubed plus 5x squared minus 4, and add 3. Okay, if I want to go down by 3, I take the entire function, put it in parentheses, and I subtract 3. Okay, if I want to flip it vertically across the x-axis, what do? I take the entire function, put it in parentheses, and put a negative sign in front of it. If I want to stretch it vertically by a factor of 3, take the whole function, put it in parentheses, and I multiply it by 3. If I want to shrink it by a factor of 3, take the whole function, put it in parentheses, and I divide by 3. So let me actually put little dots here where they're not right on top of each other. Probably should space it out just a little bit, hopefully. That makes it look a little bit better. So if I want to move it up by 3, I add 3 to the whole function. I want to move it down by 3, I subtract 3 from the whole function. I want to flip it vertically across the x-axis, I put a negative sign in front of the whole function. If I want to stretch it by 3, I multiply it by 3. If I want to shrink it by 3, I divide by 3. Those are all my vertical transformations. Okay? Now for the horizontal transformations. So here we go. Horizontal transformations are going to be a little bit different. Here we go. Let's say I want to go right by 3. So I'm going to replace every x, and I'll write this replace every x with what? Well, I want to go right, but it's a horizontal transformation since it's the opposite of what I would think, so I'm going to replace it with x minus 3. So what does that look like? Well, it looks like x minus 3 cubed plus 5 times x minus 3 squared minus 4. Okay? Now if I want to go left by 3, I'm going to replace every x with what? Well, again, it's a horizontal transformation, so it's the opposite of what I would think. So if I want to go left, I need to add 3 to every x. So I replace every x with x plus 3. So that becomes x plus 3 cubed plus 5 times x plus 3 squared minus 4. Okay? So those are the shifts. Now let's flip. So let's say I want to reflect it across the y-axis. Well, it's going across the y-axis, but so that means it's changing horizontally. It's going from left to right or right to left. So I'm going to replace every x with what? Yep, I'm going to replace every x with negative x in parentheses. Don't forget those parentheses. So this becomes negative x cubed. I should probably make that cubed a little bit better. Cubed plus 5 times negative x squared minus 4. Okay? Now, let's say I want to stretch it horizontally by a factor of 3. So if I want to do that, I'm going to replace every x with what? Yep. It is not what I would expect. If I want to stretch it horizontally, I need to divide by that factor. So x divided by 3. So every x becomes x over 3. So I get x over 3 cubed plus 5 times x over 3 squared minus 4. And finally, if I want to compress it, shrink it horizontally by a factor of 3, I replace every x with what? Yep, I want to shrink it, so I replace every x by 3 times x. So here I go. I'm going to get 3x cubed plus 5 times 3x squared minus 4. Whew. So that's how you do it. If it is a vertical transformation, put the whole thing in parentheses, the whole function. If I want to shift it up, I add. Down, I subtract. Flip it, I put the negative sign in front of the whole function. Stretch it, I multiply it. Shrink it, I divide. If it is a horizontal transformation, it is the exact opposite of what I would think would make sense. I'm going to replace, if I want to move it right, I replace every x with x minus 3. If I want to move it left, I replace every x with x plus 3. If I want to flip it, mirror it across the y-axis, I replace every x with negative x. If I want to stretch it horizontally, I replace every x with x divided by 3. If I want to shrink it horizontally, I replace every x with x times 3, or 3x. That's it. That is all the transformations right there, all in one place. So let's do one quick example of a few things. Actually, now that I've done all this, I think I'm going to jump straight to homework and give y'all a chance to knock this out. So let me clear this, and let's do some homework. So let's say that I have my base function is going to be, let's try 2x to the 4th plus 3x squared minus 7. And then let's do the following. So this will be problem 1. Let's flip it across the x-axis for part A, and then flip it across the y-axis for part B. Okay, you have to figure out which one of those is horizontal, which one is vertical. All right, for problem 2. Oh, yeah, that's cool. That's good for that. Let me try this. So base function, I had a thought, something I haven't done yet. Negative 3x to the 3rd plus 5x minus 2. And then for part A, let's stretch it vertically by a factor of 7. And part B, let's stretch it horizontally by a factor of 11. Okay? And so number 3, the base function, let's say is negative 2x squared minus 3x plus 1. And now for part A, let's shrink it vertically by a factor of 5. And part B, let's shrink it horizontally by a factor of 12. Okay? So tackle all of these problems and we'll go from there. Then I am happy to say this is the last of the content. So we're done. We're now going to be spending the remaining time this week reviewing, getting ready for an exam. So good luck with this homework. I hope you enjoy it, and I will see you soon. Take care. Stay safe. Bye-bye.